All right. Finishing up here with, or getting back to groundwater. I think when we left off, I was talking to you about beer bongs for some reason or another. But the idea was pressure gradients, okay? And, you could always put Sprite in your funnel and tube. Not encouraging anything, one way or the other. We talked about the difference between confined aquifers and unconfined aquifers, and that was having a capstone on top. So one would say, generally speaking, to have a self-flowing well is a good thing, okay? This artesian well, if you would. But they're hard to refill. They're hard to recharge. So that comes with a catch to get that capstone, So the opposite then, or not the opposite, but the other way is the pump well. And I think we talked about this a little bit. You have these little things that look like dog houses outside of people's houses. And this is the majority of the wells. Downside, of course, is you need electricity to pump water. So when the power goes out, you might not have water. A lot of people have backup generators for this very reason. They also have another disadvantage, and that is called cone of depression. Tiny little word there on the bottom. You're actually quite familiar with cones of depression. I call them the Slurpee effects. All right? Think back to this summer when you got a slush puppy or whatever you kids call them these days, and you suck, trying not to get a brain freeze, and then all of a sudden you're like, where's my, you can feel the cup, there's still stuff in there, it's still nice and heavy, but you've cleared out that area around your straw, right? You got to shake it a little bit, move the straw around, and get stuff back down in there. That's exactly what's going on with cone of depression. When you have the pump turned on, it clears out the area around the pipe first. All right, that's it makes sense. It sucks all the water from around the pipe first. What you need to have then time for is the area around that pipe to fill back in, which is a permeability issue. Right? Remember, permeability is the flow. And again, they've calculated for this. They should have calculated for this before they even decided that this area can survive off of groundwater. All right? You got plenty of water in the ground. It's fairly easy to get it out. Everything is fine. Except, occasionally, if we overdevelop and something like the holidays rolls around. So, as an example, when I think it was after grad school, it was one of my first teaching jobs. We were out in the Midwest, out in Toledo, Ohio. All right, south of Toledo, Ohio, actually, in the cornfields. So, the landlord had bought a big old farmhouse, split it into 3 apartments. We had one of those apartments. He then had 2 elderly couples set up, very nice, tasteful kind of looking places, but 2 trailers further out on the land. And still, on any given day, all 5 of us, if we ever coincidentally did do our laundry or whatever at the same time, we really didn't have too many problems. But when the holidays came around and people had company and so on and so forth, there were times when we would turn on our spigot and it would go, it'd sputter all over the place. And again, if you have well water or you know someone who has well water, you may have seen this happen. All right? The flow doesn't meet up to your expectations. So that is a recharge issue. It's not very common, and if it is a common problem for you or someone you know, you better get the stuff checked out. You might need to make your well go deeper or some such thing. All right? But cone of depression. Okay? It's the drawdown, which clears out around the pipe, and then it doesn't trickle back in enough time to keep a constant flow. But again, these are really easy to recharge, so that's why we like unconfined aquifers, even though you have to pump your own water out. And it still beats lowering a bucket down a hole and carrying that up and down the hill like Jack and Jill. So, I really don't know why they were getting their water from the top of the hill. The bottom of the hill, probably, but whatever. So, in case you missed or forgotten, here's a nice little summary. And it is not artisanal water. It's not fancy cottage-made water. It's artesian. And then versus a pump well. And there is a question or two that asks you to distinguish between these, okay? So, do sort it out. We talked about springs already in passing. I think it was when we were explaining unconfined aquifers and how shale can stop water or cause water to back up, build up. And then I said if it happened to intersect with the landscaping, that you would have water leaking out at the surface. All right, that's a spring. And like I said, if we do get to talking about streams this semester, one of the first things you'll learn is that we don't mess around with all these other names, rivers, creeks, brooks. We call everything a stream in geology, except a spring. Because a spring is groundwater leaking out at the surface. A stream is surface water, always. So that's a big, big, big distinction. You might not give a rat's behind yourself, but to folks that study this stuff, it is a big, big difference. And this is also how you get all those wonderful, nutrients and stuff in it that makes these special. To go back to artisanal for a moment, this is why you're buying your Perrier or your whatever, Crystal Springs and all those cool. Poland Springs is one I was trying to think of. Because of the unique chemistry that their area puts into the water, so on and so forth. So groundwater is definitely different than surface water. Do you need to know 5 different ways that it can happen? No. This is just an example. And a little bit of foreshadowing, too, if you look at those. What are those bricks? What kind of rock type are the bricks? Shale. Shale's the tire tracks. So the bricks is limestone. Yeah, you're also going to see that question.
I was looking at the wrong one.
Yeah, so okay. That's another question you're going to see on the final. Those pictures of the rock types. Okay? Gotta learn those. Dots, dashes, bricks, and asterisks, or whatever you want to call them. No smiley faces, probably. All right. We said we weren't going to talk about streams, but here we are. Well, we're talking about streams right now because this is in the context of groundwater. There are, generally speaking, 2 types of streams out there. Ones that are in contact with the water table. Remember, the water table is that level of underground water, all right? And streams that are above the water table. Generally speaking, where does a stream get its water, you guys? No. Just a river, a stream, outside. What's its source for? Generally speaking, most people would say
lake.
Okay, a lake. Where does that lake get its water? Rain. All right. So looking for precipitation and or snowmelt. That's generally what feeds. You're not wrong. Okay, but what I was fishing for is precipitation and snowmelt. Okay, that's the typical thing that feeds surface water. A gaining stream is also fed by the groundwater, the water table. So that's why it's a gaining stream. If you hit a dry period, you still have that little bit of groundwater maybe to get you through so you don't dry out your stream bed, so on and so forth. A losing stream, on the other hand, a losing stream is fed by precipitation and or snowmelt, but it is, for whatever reason, above the water table. So also, instead of just flowing downhill, it's also trickling down into the earth. It's losing water to the water table. These are the guys that tend to dry out, what we call intermittent streams. You've seen them when we did topographic maps. Instead of a solid blue line, it was a dashed blue line. Sometimes they're there, sometimes they're not. A gaining stream is way less likely to go dry. So that's why this is here, because it is related to groundwater. Subsidence. Subsidence is important. Subsidence happens a lot, and it's not good. I like this picture because it reminds me of what I remember of my great-grandfather. Tiny little Italian man who always had on a short-sleeved white shirt with something in his pocket and a silly little hat. All right. This looks exactly, he died probably a few years before this, so that's probably what little men all look like that, I'm guessing. But that's not why he's standing there. That's not my great-grandfather. He's in the San Joaquin Valley, and to me it looks like he's standing next to grapevines. That's a little old Italian men should. But one semester, one of my students raised their hand and actually spoke in class. It's quite an oddity. And said, San Joaquin Valley is known for avocados. I'm like, all right, well, maybe he's standing. I think avocados come from trees, though. But I wasn't going to argue, and they might be shrubs at any rate. Point is that they are growing a lot of vegetation in an area of California that doesn't get a whole hell of a lot of rainfall. So you've heard of irrigation, right? Irrigation pulls water and gets it to where it needs to be, and oftentimes gets it from places far away. But trust me, before they went into that, they used all their available local water first. And that's what subsidence is. Subsidence is a sinking or a compaction of all the loose stuff on top of the bedrock. You're not collapsing bedrock, but all the soil and stuff on top of it. It settles when you remove all the groundwater from it. It sinks. And you're like, okay, I can see that. I believe it. But this is extreme. So you see that telephone pole there, and you all know roughly how big telephone poles are. We are to assume that all the way up at the top, 1925, and that little old man was probably still there doing his whatever he does, tending to his avocado grapes. And the ground level was that high. 30 years later, 1955, the ground level was that high. And then in the current time, 1977, the ground level was that high. That's a lot of sinking. It's a lot of sinking. That's a lot of groundwater removal. That is, I have to imagine, really extreme. I don't know a huge amount about subsidence, but that's a lot. And then I also have other questions. Like, did it all settle equally? Why aren't the roads a shambled, crumbled mess, and houses, and so on and so forth? But that's certainly the implication of this picture. All right. Either way, it serves as a great introduction to talking about subsidence, okay, which again is a compaction of the pore space, to use technical terms. Remember, we said you got all those pieces, parts. You got one or two things in between them. You got water, you got air, and water. So when you boil them up, you fill them up with water, and then you pull that water out really quickly, it's going to settle. You can compact a lot more than it ever previously was. Plus, again, all the trucking, okay, to move that vegetation out of there, be it grapes or whatever. There's a lot of rumbling, which does settle stuff into place too. So that's subsidence, and it is an issue. What we know more potentially about subsidence is in coastal areas. All right. Unfortunately, it's a misnomer when we talk about it in coastal areas, like New Orleans is a great example. New Orleans is being erased off the map. A ways back, you guys were, I think you were born. They had that horrible hurricane down in New Orleans. Katrina. Were you guys alive for Katrina? Barely? Thereabouts? It was early 2000s, I think. If not late 90s. I think it was right around there. Anywho, got a huge amount of press because New Orleans is essentially like a soup bowl because of subsidence, or what we're going to talk about. All this flooding came in, and it stayed there. It's absolutely horrible. And then all this other stuff came to light about how they hadn't been taking care of their levees and this, that, and the other thing, and a lot of blame got thrown in a whole lot of directions. And understandably, everyone was upset and so on and so forth. But subsidence kept coming up because there's New Orleans is sinking. New Orleans is sinking. No, New Orleans is being erased. It's different. So New Orleans, if you don't know, is on the Mississippi. And the Mississippi is a wonderful shipping port, okay? For all of you that complain about semis on the road, you want more shipping, you want more trains, okay? So shipping is still important in this country, but it is limited, of course, to these major waterways. So in order for that to happen, they dredge. They set up, the Army Corps of Engineers and a handful of other folks, they go in and they keep these river channels clean. So these giant boats can get in and can get in nice and far, and so on and so forth. Well, we haven't exactly talked about streams yet, but one of the things that you might have picked up during weathering and erosion conversation is that streams transport sediment. All right. That Mississippi River, for the thousands and thousands of years millions of years that the area called New Orleans has been there, has been flowing downstream, hitting the ocean, which is essentially a brick wall compared to a stream, and dropping its sediment, building that land. Now, it didn't exactly get bigger because the waves are always hitting it, and waves like to erase things. So you had a constant streams bringing sediment, waves washing away sediment. New Orleans, more or less, and you could put this anywhere on the coast, really, but here in particular, because the Mississippi's there. It was more or less a standstill. Then we put in our sediment traps, and I started dredging so we could keep it clean for commerce. Well, you see what we just did to the equation there. We didn't do anything to stop the waves from wearing it away. We only stopped the sediment from coming in. So New Orleans is slowly being eaten away by the waves, and we don't have the sediment coming in anymore. So it in effect is sinking by what looks to everyone, but it's actually just weathering and erosion. So subsidence gets used that way, okay, and it's completely wrong, unfortunately. So I just felt I needed to spend 3.5 minutes of your time to explain that. Karst. Gotta love karst. Actually, everybody loves karst until the worst case scenario happens. Karst is why you guys have house caverns. All right. Karst, again, is named for a place. And what happens is that water eats limestone. Any of these famous caves that you know and love, they're limestone. And what happens is that the water gets in there, and this is over thousands and thousands of years. Okay, not just a weekend. And it dissolves the rock. Then things change climate-based wise, and that area, the water goes away, and then you're left with these caves and crevices and whatnot. That's when your stalactites and stalagmites can grow. And then maybe sea level changes again, and the water level goes back up, and some more of that gets dissolved out. Again, it happens cyclically over and over tons and tons of years. But the net result is that from tiny cracks in limestone, bigger cracks come, and eventually you get caves forming. Karst, strictly speaking, is water and limestone interactions, okay? What it gives us are caves, stalactites, stalagmites. And something else that's called a column. That's when stalactites and stalagmites meet. What were you guys given over the years to remind you which one is which, a stalagmite and a stalactite?
Stalactites are the ceiling, the sea and ceiling.
Ah. Anybody else? I heard such wonderful thing like mites. Mites are bugs, and bugs love to crawl on the ground. I'm like, well, bugs like to crawl on the ceiling too. So that never helped me. And yeah, I did finally come across, all by myself, I think, sea ceiling, stalactite ceiling. Okay. Now, if you mispronounce it and you say stalactites and stalagmites, which a lot of people do, then you know that nothing to help you. But if you call it the right word, stalactite and stalagmite, G ground, C ceiling, all right, you can keep them separate. But yeah, mites, bugs love to crawl on the ground. That's what my teacher told me 100 years ago. Those are dripstone formations. Again, very, very slowly. If you've taken the house cavern tour, which is my understanding that pretty much every child that grows up in Utica does, you've heard all about this, and you shouldn't touch them. These are by far not my favorite dripstones. I like those big things that look like the wedding cakes. Big flow, that's a flow stone instead of a dripstone. But stalactites and stalagmites can be quite cool, no question about it. And everybody loves to see them. Many, many stories about pirate caves up and down the East Coast and the West Coast as well. But many, many stories about that, and even on the Great Lakes for the rum runners when Prohibition was around. This is more along the lines of the coastal though, because you need the tides. And one of the old stories was always, this cave that's only accessible during a certain time of the day, or maybe even during a certain time of the year, I should say, because tides could, keep the entrances covered, and only at an extremely low tide could you and somebody get in with a rowboat and get your booty out, and so on and so forth. A lot of that is totally true. Florida, for example, is entirely limestone. It's all just coral reefs sutured together. There's hardly any real rock in Florida at all. And again, up the coast, there's a whole lot of this going on. Recently introduced my youngest daughter to the Goonies, and it's never going to be as extreme as a pirate ship, an entire pirate ship with tide levels. But hey, that's Hollywood for you. But certainly a couple guys in a rowboat, yeah, you definitely could have scenarios where you would have to wait for the lowest tide of the year in order to get into a certain cave and so on and so forth. That is kind of, I don't want to say true, but could be real. So there's a lot of karst topography. Topography is the lay of the land, all right? And so there's a lot of features that can happen with it. But you guys know caves and caverns, stalactites and stalagmites. I got a couple minutes left here. I just want to power through this. As I said, worst case scenario with karst is sinkholes, all right? We told you that slowly but surely this area gets eaten out, and we oftentimes don't know what's happening. The water level changes. The water level was buoying up something for hundreds of years, and then we again start pumping out water to feed a new development or to start a new bottled water company or whatever. The groundwater level in the area lowers, and you're left with basically a giant hole underground. And all it takes is some stupid thing one day, a truck driving by heavily laden with God knows what, and it rumbles something loose, and the whole damn thing collapses. It's a little hard to get scale on this, but if you look at that road, I think you got 2 lanes going one way, 2 lanes going the other way, so that's sort of a 4-lane road there. There's buildings along the bottom here. If this wasn't a factory complex, it was certainly, something like a mall. That's a big stinking hole, okay? And again, quite possibly they got little to no notice that that was going to happen. Sinkholes can strike without any warning whatsoever. You could also get a slow sag, but again, you never know when something's going to happen. I just saw this. I've been looking at this picture for a very long time. I think there's a trailer right there.
How big deep can a sinkhole be?
It can be quite. In this one, I'm guessing, again, it's really hard to get scale. We're looking, 50, 7,500 feet. But it could be as deep as it wants to be, for lack of a better word. Last thing, and I do have, I have 1 minute. Please give me 1 minute. You hear about sinkholes opening up in downtown city streets a lot. That ain't this, okay? Again, water transports sediments. Many cities have very old plumbing systems, leaky water pipes, leaky sewer pipes. Over time, those clear out the area underneath the blacktop and around the pipes. Again, some poor sap pulls up in his UPS truck, jumps out to run in the subway, comes back, finds his truck fell into the road. Happens with some frequency.
There was a sinkhole in Waterville, actually.
I drive by that one quite frequently.
And it was like 3 years ago, before COVID, they saw it patch it up.
Yeah, it's still there. Or we go to the dog kennels out that way.
Isn't it like there's like a tunnel or something under?
Well, that one I can't be specific on. There probably was a tunnel that led to something. It's right in front of a school building, which is now apartments. But also, I'm guessing there's this leaky plumbing that I'm talking about as well. So again, that's not a sinkhole per se because it has nothing to do with karst. All right. Did the land collapse? Yes, but that is probably because the leaky pipes over decades cleared away a whole bunch of sediment that used to be there supporting the road, and then again something stupid happens one day and the whole thing collapses. So the news doesn't always know what they're talking about. Just an FYI, especially when it comes to science. Sometimes they do, and they're getting a whole heck of a lot better thanks to Googling. Okay, but still not always. All right, that is the end of groundwater. Please read the chapter. Please read the chapter.